This code implements Kruskals algorithm which finds the minimum spanning tree of a given graph. A tree is a subset of edges that connects all the vertices with the minimum possible total edge weight and no cycles. Let's break down the code step by step. Graph class. The graph class represents a graph with vertices and edges. Self.v, the number of vertices. Self.graph, a list that holds the edges of the graph. Each edge is a tuple u, v, w, where u is the source and v is the destination, which are connected, and weight in w is the weight of the edge. Init, initialization. The init method initializes the graph with a given number of vertices self.v and creates an empty list self.graph to store the edges. Adding the edges. This function adds the edge to the graph. It takes two vertices u and v and a weight w and appends this as a tuple u, v, w to the graph list. The root of a set. Find function helps to find the parent or root of vertex I. It is used to detect if two vertices are in the same set, that is, part of the same tree. If the vertex I is its own parent, it returns I. Otherwise, it recursively finds the root of the set it belongs to. Union of two sets. This function matches two sets trees that contains the vertices x and y. It compares the ranks of the sets to keep the trees balanced and makes the root with the higher rank the parent of the other root. If both ranks are equal, it picks one root and increases its rank. Now, Kruskals MST algorithm is implemented as follows. This is the core of the algorithm. Sorting edges. First, the graph's edges are sorted by weight. Self.graph equal to sorted of self.graph, comma, key equal to lambda, item implies item of 2, so that we can pick the smallest edges of first. Parent and rank arrays. Parent keeps track of the parent of each vertex and rank is used to optimize union operations. Main loop. The algorithm goes through the sorted edges one by one. For each edge u, v, w, it checks if two vertices u and v are in the different sets using find. If they are in the different sets, the edge is added to the result. Result.append u, v, w, and the sets are merged using union. This continues until the MST have v-1 edges, where v is the number of vertices. Now printing the MST. This function prints the edges and weights of the minimum spanning tree. Example uses. Here we create the graph with the vertices